4-1, we are talking congruent triangles. And congruent triangles are triangles that are identical, which means everything about them is identical. So if you look at these two pictures here, okay, congruent triangles have congruent corresponding parts. What I mean by that is side AC on one triangle is going to be congruent to the part that looks just like it on the other triangle. So in other words, we can say that angle A is congruent to what on my blue triangle? Angle D. Okay, we can say that angle B is congruent to what on my blue triangle? Yeah, and how do we know that? It's the three markings, right? Those three arcs, congruent to the three arcs. That's how they're going to mark everything congruent for you. So then we can say angle C is congruent to angle F. Okay, so all three angles are congruent to all three angles if our triangles are congruent. But it's not just the angles, okay? It's the angles and the sides. So we can also say that segment AC is congruent to what segment? DF. So three markings matches up with three markings. AC is congruent to DF. We can say that CB is congruent to FE. And it doesn't matter if you flip those, right? BC or CB, it doesn't matter which way you say that, they're the same. And then the last one, AB is going to be congruent to DE. Okay, so here's what I want you to notice. In two triangles, there are 6 things that match up. Angles, so there's 3 sets of angles, right? And 3 sets of segments. That's all 6 parts of a triangle that will have to be the same if the triangles are congruent. Rather than you have to go through a proof and say, here's why these 2 angles are congruent, here's why these 2 angles are congruent, here's why these 2 angles are congruent. I'm going to give you shortcuts that tell you you don't have to find all 6. As long as you know a side, an angle, and a side, they'll still be congruent. So we'll go to those shortcuts in just a minute. But there's one theorem that gets talked about in 4.1 that will show up from time to time in 4.2, 4.3, 4.4, all of those. And that's called the third angles theorem. And it's exactly what it sounds like. It's all about the third angles in a triangle. So what it says is if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent as well. Okay, and I'm going to show you a picture of what this would look like. You may draw this with me if you want, or you can just watch what we're doing here. If I have these 2 triangles, okay, the third angle theorem, I'm going to call this ABC and this DEF. If I know that A is congruent to D, and I know that B is congruent to E, okay? Why would I know? Because third angles theorem says C is congruent to F right now. Why do I know that? Yeah?
Because A, B, and C, all of those 3 angles have to equal 180, so does D, E, and F.
Yes, right. So if the angles have to add up to 180, and I know these are the same, and I know these are the same, then C and F have to be the same in order to add up to 180, right? So that's the third angles theorem. Third angles theorem here would say, I know, even though it's not marked, I know that angle C is congruent to angle F. Okay, that's the third angles theorem. So look for that when you're doing proofs. If you know 2 of the angles are congruent, do I know the third as well? And you will. Okay, so 4.2. This is the main show today. We are going to do triangle congruence by SSS and by SAS, okay? Which sounds foreign to you because we've never talked about SSS or SAS, but let me explain what those are. So SSS is just side, 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 okay? You do not have to write side, side, side. You may use SSS every time. Here's what the SSS postulate says. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. Okay, so remember what I said. Technically, we need to know for congruent triangles, 3 sides are congruent and 3 angles are congruent. Now we're saying if the 3 sides are congruent, the angles will be congruent also. Okay, so all you really have to know to prove these 2 triangles are congruent is we would say triangle ABC is congruent to triangle, and here's the thing, you have to name them in the same order. So if I name it ABC, like that, then I have to name it DEF. I have to start with the single to the double to the triple, okay? You may pick whatever order you want, but you have to be consistent. So if I said triangle CAB, what triangle is that congruent to? FDE, yes. Okay, so make sure you name it in the exact same order so we know what parts match up. Okay, because right now we're saying that A corresponds to D, and we're saying that B corresponds to E, and we're saying that C corresponds to F. Okay, you have to match up the corresponding parts. Does that make sense? Okay. When talking about triangles, we call triangles rigid figures. Basically, if you think about having a triangle, I wish I had a good triangle here. I really don't. If I take a triangle like this and I push on this edge, when that edge starts to tip down, the other leg is out here. It doesn't make that same triangle anymore, right? Whereas if you think about like a parallelogram, if I push on this edge, my parallelogram can just get steeper, right? And I can still have a parallelogram. Triangles are not that way. As soon as you push on one of the sides, it's going to make the other side shorter, okay? Yeah.
Isn't that why triangles are considered like the strongest shape to build?
Yes, precisely. Yes. So triangles are what we call rigid figures. We cannot take a side and shorten it, which is why SSS works, because my sides have to be those 3 lengths. You cannot get a different triangle from those 3 lengths. So that's why we can say SSS is true, because the 2 triangles have to be identical, okay? So can you name a figure that's not a rigid figure? You could say a parallelogram, a rectangle, a circle. Never thought about that. I was thinking all polygons. Circle's not a polygon. I suppose you could misshape a circle to make it more an oval. Okay. Are you ready? Here we go. So we're going to use that SSS idea. Okay? Here's our very first proof of this chapter. Copy and paste, by the way, can still be your friend, just like we were doing before. Tell me what goes here. The given information. So if you want to just copy and paste that, I'm not going to rewrite it all. You don't have to rewrite it all. That's going to go here. Okay? The information they gave us as the given goes in that first blank. And my answer, my reason for that is given. Okay? Now, before you try to figure anything else out, look at what they're asking us to prove. They're trying to get us to prove that this triangle here, okay, this triangle is congruent to this triangle. So let's just think of those as 2 separate triangles right now. We can either prove all 3 sides and all 3 angles are congruent, or we can take a shortcut. Our shortcut was SSS. Can you prove that all 3 sides of the purple triangle are congruent to all 3 sides of the red triangle?
Yes.
How?
Because it tells us that, because right there it says L and M are congruent, it's more congruent symbol to P and N. So we know those 2 are congruent.
Okay.
And we know NM is congruent to PL.
Okay, so they told us this, right? This was our given information. These are congruent, and those are congruent. So we have two of the sides given to us that are congruent. Do you know the third side is congruent to the third side of the other triangle?
Yes, because they both share LN.
They're the same segment, right? So we're basically saying LN of the purple triangle is congruent to LN of the red triangle. What property is that? Reflexive, right? That's the reflexive property. So you kind of have to think of it as separate triangles, but they really are the same segment, right? LN on the one triangle is congruent to LN on the other triangle because of the reflexive property, okay? Look for the reflexive property. You're going to see it a ton in this chapter. So if ever you're like, I don't know, what do I have to do? Look for overlap. Look for places where the angles are the same or the sides are the same in your triangles, okay? Okay, what goes here? Whatever it is you're trying to prove, right? You're going to take this prove information. Oops. Triangle LMN is congruent to triangle NPL. Okay, now here's the deal. When you write this step 2 in, I would mark it because that's what helps you to see what's going on. So you mark LN congruent to LN because now you should be seeing that a side, and a side are congruent to a side, and a side. Do you see it? Okay, we can say those two triangles are congruent because they have the SSS set up. The three sides of the one triangle are congruent to the three sides of the other triangle. Does that make sense? Hopefully. Tell me if it doesn't, and I will try a different way. Okay, so that's SSS. We're going to talk about another one also, and that one uses some terminology that you've maybe not heard before, and that is the included angle. Okay, when we talk about an included angle, think about if you want to be included with your friends, you want to be in tight with them, right? An included angle is the angle that lies between the two sides that we're looking at. So let's say you had two triangles, and one of the triangles marks this congruent to another side, and one marks this congruent to another side. The included angle then is the angle between those two sides. So what would my included angle be here? Angle A. It's the angle that forms the two sides that we're working with, okay? So my included angle in this picture is angle A, okay? That comes into play with SAS, and SAS is side, angle, side. So SAS postulate says, and this is important because it doesn't work if it's not the included angle. It says if two sides and the included, sorry, that's really messy. Try again. And the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So basically what they're saying is if you have a side that corresponds to a side that corresponds to a side, and the angle between them, angle and angle, okay? If you have that SAS set up, those triangles must be congruent. There is no other triangle you can make with those side lengths and that one angle, and it will be a different triangle. They have to be congruent, okay? So we're saying here, if I say triangle, let's say I say triangle BAC, what triangle is that congruent to? BAC would be EDF, yes. Is my door still locked? Oh, that's how you guys got in. I was like, I swore my door was locked, but you guys snuck in because someone pushed my little thing. So BAC is congruent to EDF. BAC is not congruent to FDE, right? You have to name them in a corresponding order by the side angle side postulate. You have a side, an angle, and a side that matches up with a side, an angle, and a side. And if I could just encourage you, if you can already tell this is going to be a struggle for you, I think this, thank you. I think this is hugely helpful, just labeling your letters, because sometimes people mix up what are the sides and what are the angles because you're just looking at a letter. Just remember the sides are segments, the angles are the vertices that those segments meet at, okay? Side, angle, side with side, angle, side. Okay, so let's look at example 2. It says, what other info do you need to prove triangle DEF congruent to triangle FGD? They have told us this, and we want to prove them congruent by side, angle, side. Is there anything we know to be true that just isn't marked for us yet? Any side or any angle, John?
Two sides on the right.
Two sides what?
Two outside and side vertical lines are congruent.
Okay, but we don't know that those are vertical. They look vertical, but no one told us they're vertical, so we don't technically know that. Julia? Yeah, we do know, without it even being marked, we know these are congruent, right? FD is congruent to FD. So that is technically given to us, even though it's not marked for us, because it's reflexive. We know the reflexive property says those have to be congruent. Okay, so if we know that information, what's the missing piece of information that would make SAS happen? Here's a side that corresponds to a side that corresponds to a side. What angle are we looking at? What do we need for SAS? Remember, it's got to be the included angle. Julia.
Is it angle D or F?
What is angle D? There's two angles there, right? How do you name an angle if there's multiple angles with the same vertex? 3 letters. So if you look here, it's going to be this angle is between these two sides, right? And this angle is between these two sides. So we would have to know that angle EFD is congruent to angle, how would you name the other one?
FDG.
You can say FDG or GDF. It doesn't matter the order on that because you're just naming the vertex, right? So those two angles would have to be congruent for SAS to work. Do you see that? Yeah? Okay. Okay, so on the little like practice things that we're gonna do, the little practice quizzes, you'll see a lot of these, and this is on your test. This is an entire page of your test. I think there are 6 of them on your test that look just like this, okay? By the time you get to the test, you'll have learned other shortcuts. For today, we've only talked about SSS or SAS. So we're gonna say, can we prove these two triangles congruent by SSS, by SAS, or if not, then we have to say not enough info, NEI. Okay? So look at letter A here. Do I know that those two triangles are congruent? And if so, how? Yeah, Bradley.
They are congruent because all the sides are marked as congruent.
Yes, they are congruent by SSS, right? This side with this side with this side, and this side with that side. So if all 3 are marked congruent, now here's the tricky part. You have to name them appropriately. I can say triangle ABC is congruent to what triangle?
X.
X.
So if I went ABC, I went through the double to the single marking.
X, Y.
So it's got to be double to single, X, Y, Z. Do Do you see that? You want to name in the same order. So ABC is congruent to XYZ by what? SSS. Good. Okay, now look at letter B. Look at what you have. You have this side here congruent to this side here. You have this side here congruent to that side, so BC and PR. And you have an angle congruent to an angle. Are those triangles congruent? They are. By what? SAS. Okay, now here's where it can be a little bit tricky. You have side angle side because it's the included angle on both of them, right? You got to watch out, make sure it's that included angle. Anyone want to try to give me the congruent statement? Triangle what congruent to triangle what? I'll start you. ACB. Triangle ACB is congruent to what triangle?
PRQ.
ACB goes through the single marking, through the double marking, right? ACB. So you need to go through the single, through the double. So QPR. Does that make sense? Okay. By what? SAS. Side, the included angle, and the side. Okay, look at letter C. Are those two congruent?
Yes.
By what?
SSS.
SSS. Anyone see a different way that they're congruent? It's not reflexive. There's nothing they share except for a vertex. It's reflexive if they share an angle or they share a side perfectly. But do you see angles that are congruent?
No.
What kind?
Vertical?
Vertical, yeah. So even though this isn't marked for you, remember we said we know vertical angles are congruent even if they're not marked. So this one, you technically could have said SSS or SAS. They both work. Tell me the triangles that are congruent. So if I say ABC, what is that congruent to? A, B, C, E, D, C. So through the triple marking, through the double marking. So you need to go through triple, through double. So E, D, C. Okay, and you may say by SSS, or you could have said by SAS. They both would work. Okay. Okay, look at letter D. Are those triangles congruent? Wait. So you have a side with a side, an angle with an angle, and a side with a side. But if you follow the order, this is the included angle on the left side. Is it the included angle on the right side? No. Right? This one is ASS. And let me just tell you, there is no donkey theorem. Don't swear at your teacher. Never write the word ass on your paper. I promise you it's wrong every time. Okay? There is no such thing as the donkey theorem. So if you ever come up with ASS, just know I'm wrong. I should not be swearing at my teacher. This must be wrong. Don't do it. Okay? So for this one, we would say there's not enough info. It might be that these are congruent triangles, but based on the information they give us, we don't know it. Okay? Questions on that? Okay. Last thing we're going to do then. Oh, I don't have this up here. Whoops. That's okay. I'm going to do 2 of the homework problems with you. I think they're still on your homework. I should check that. Did I change these numbers? Anyone have the numbers in front of you?
I think it's 8 through.
This might be on the part B.
Through 30 even. The 8 through 30 is even.
Okay, but for to be 26, oh, I took these off. Well, that was convenient. Okay, so this is what your homework questions are gonna look like, and we're just gonna do these two together, okay? Because I just want you to get familiar with it and feel comfortable with it and see how we do this. So 2 proofs, and then we're done. And then I'll give you the rest of the time to work. You need to cross your midline real fast? Turn your brain back on, shoot a bunny. Okay, so let's look at number 9. First of all, look at what they give you. It says, given that IE is congruent to GH, so they marked that. Okay, and if they don't mark it for you, you should mark it. Always mark what you know. They also say that EF is congruent to FH, HF. And then this last piece of given information says F is the midpoint of GI. Here's what I want you to note. Maybe write this somewhere. Whenever you see the word midpoint or the word bisect in your given, somewhere in that proof, it is going to be the definition of whatever that thing is. Definition of a midpoint or definition of a bisector. Okay, when you see that word in your given, I promise you, you will use definition of that word in your proof. Okay? Okay, so what is the first step of this proof going to be? The given. Every single time, you guys. Please don't get that wrong. Some of you got that wrong on the test. I wanted to cry. Every single time, it is the given. Okay, so this is going to go here. I'm not going to rewrite it. The reason being, it is given. Okay, so now you think about what that given information says. We already marked the 2. What does it mean that F is the midpoint of GI? What are they trying to get you to see with that? What does it mean to be a midpoint? It's in the middle, which means we have equal parts now, right? If F is in the middle, then we can say IF is congruent to FG. Do you see that? Because they told us it was a midpoint, we know those 2 segments are congruent. So the reason is definition of a midpoint. Are you tracking with me? Is this making sense? Okay, now they asked us to prove the triangle's congruent. Have we done that? Do you have enough information right now to say those 2 triangles are congruent? What? SSS. You have the 3 sides of the one triangle matching up with the 3 sides of the other triangle. So we're going to say, last step is always what they asked you to prove, right? We're going to put this here. Triangle EFI is congruent to triangle HFG by SSS. See, these proofs aren't terrible, right? You guys are going to do great. Okay. Questions thus far? Do you want to try this one by yourself? Are you sure? I kind of want you to try it by yourselves. Just not feeling confident enough for that yet?
Got this. Do it.
Yeah, try it. Try it by yourself, real quick. Take like 2 minutes. Try that proof. 29. You should already know this whole row and this number 4 blank on the left, right? So you really just have 5 blanks to fill in. Think about what I told you about words in the given. See if you can get there. More good news for you, by the way. Friday, I'm not teaching you anything new. We're just recapping this. So it's just try it again. Let's see how it goes. Ask me all your questions, and then I'll let you try some more proofs. So hopefully that's a good thing. Uh-oh. Maybe stop working. Anyone think they got it? Jonathan? Jessica, maybe? Okay, let's talk through it. What's going to go in blank one? The given. So we're going to take all this. AE and BD bisect each other. Okay, the reason for that is it is given. Okay, now your job is to think about what does that mean? What does it mean that AE and BD bisect each other?
Cut in the middle.
It's going to be definition of a bisector. It's cut in the middle. So what do we know on the left side? What do we know to be true? If AE and BD are cutting each other into equal parts, they are bisecting each other.
AC is
Yes, AC is congruent to CE. And whenever the reason is the same, we always just make it one step. So AC is congruent to CE. What else is congruent? BC is congruent to CD. Okay, so make that the same step. The reason for that is definition of a bisector. If you see that word bisect or midpoint in the given, I promise it's definition of a bisector when you give your next step, okay? Might not be the next one, but somewhere in there. Okay, so right now you have two sides that match up with two sides. Do you see anything else that has to be congruent about these two triangles?
Is angle C vertical?
Yes, you have vertical angles, right? So we can say, now you can't call it angle C because they're two different angles, right? So we would call it angle ACB is congruent to angle DCE because they are vertical angles. So what's my fourth step? Your side angle side, right? What they asked us to prove. So they asked us to prove the triangle's congruent. So we're going to put that right here. Triangle ACB is congruent to triangle ECD because of, notice, side angle side and side angle side. So SAS. How'd we do? Does that make sense? So these aren't the worst, right? They're pretty straightforward. They're going to feel very repetitive. You'll do a lot of the same steps, a lot of vertical angles, a lot of definition of a midpoint, definition of a bisector, a lot of reflexive. So look for those things, okay? Some of you might even want to just start a list somewhere in your notes, wherever, of here's common things that are going to show up in my proofs. If you want to do that, here's a list for you. So far today, we've seen given, right? That's always going to be your first step. We've seen definition of a midpoint. We've seen definition of a bisector. We've seen vertical angles. We've seen the reflexive property. And we've seen SSS and SAS, okay? These guys are going to show up a lot in proofs. So if you're uncertain, if you're like, shoot, where do I go next? See if there's a place that you can plug one of those in. There probably is. Good? Okay.